we can see that we can also give a qualitative solution to the deflector shape as in this diagram. We know that it will hog between this point to this point, it's hogging, and no deflection at points A and B. That's not be any deflection at this point A and B, that's why here zero deflection, and with the load direction it will displace there to be a deflection at the load point in the direction of the load, as there is no bending in the one portion C and D, it will not bend, but this portion is attached, deflect and rotate, because it is attached to the ABC portion, right, which bends. Note the congruence between the deflector shape and the bending diagram. This is the deflection shape, this is a bending diagram. So this hogging is somewhere here, it's coming, so tension is this side, so completely here also tension only. That's why this from this point it's going up, and then it's zero is coming. That we can see it in another example. STAAD Pro. So we will go to this grids. We will create 4 nodes. So we have created 4 nodes, and then we will go to this properties, material, and section database. We will apply a beam of simple section, and we will give the support conditions, and the boundary will give one simple beam here, add it, and then assign to the view, it's assigned, and then here we will give this support points. We have pinned support, and then create a roller support. In roller support is nothing but fixed butt, and we are releasing everything. Fx release, Fy release, and Fz we are not releasing, and remaining all moments we are releasing it. We will add it. So here we have to see the nodes, and 10 or all 10. We can see the labels. We will create labels for these nodes, node numbers, and node points. So here we can see the node numbers and node points. We will delete these nodes, unnecessary nodes. Here we have the 4 nodes starting from 3, 4, 5, 6. Here we will put this as a pinned support, and then here or B point we will put the fixed butt support. That means like this support, if we see, it should be restrained only in the Y direction. It should be release all effects of it, only Y, it should not be released. Change it. So here we can see it. Now we will apply the load at here. Go to the loading and create a new load, and load case we will see load case 1, and at this load case we will add the support load point in Y direction minus 10 kilonewton. Add it. So here we will go and use this cursor to assign. So this is, once we do this one, then we will go to the analysis and design and define comments and print it, and then we will run the analysis. So let's go to the post processing. Here you can see view, how the deflection happens. You can see from here to here it is a straight deflection, but still it is going straight line, but it is deflecting and rotating because it is attached to the 3, 4, 5 joints, right? And load value also we can see the load value. Loadings and reactions, if you see the reaction, so here load is 10 is applied, here 15 is the upward, and here is the minus 5, because if we see here, since the load is applied here, if there is no support here, what will happen? It would go like this, right? It's a pinned support, only support is here means, so something should be that to bring it down. That's why the reaction is downward directions minus 5 kilonewton. So this will be held in position, so reaction will be downward, and since this is minus direction, this is also minus direction, this is 10 kilonewton, this is some value, it will be there, both it will be coming. So this location, the force should be, reaction should be more than this value. If I take this point about the moment, 10 into this distance, that is the lever arm. Since the lever arm is more, but for this reaction maybe lever arm is less, force would be more, then only the moment will be equal. So moment 10 into this distance, say for example 5 meter, that means 50 moment it will come. This distance it will be less, right? So if this distance is 4 meter, so I can get like if this is also equal to 10, then 40 only it will come, but this is not correct. So this should be more than 10. That's why VB is always more to maintain the, to satisfy the equilibrium of a moment. So VB should be more than W value. So here you can see this is the downward direction, because if there is no support, if you apply load, it will try to rotate like this. So something should be there to pull it down. That's why force is coming like this. So reactions okay, and bending moments, if we say it, since there is no force in this portion, force is here only, this point only, there is no force here, there is no moment. From this point, if we take this force into distance, that is 10 into the distance, that value, if we see it here, 10 starts, and then loading, it becomes, it's a 1 meter distance length, so 10 into 1 is 10, that's what it's coming here. And if we see here, from 10 it will linearly, it will reduce and to go to 0, because it's a pinned support. So, and reaction we have seen, it's, this is how much distance is the 2 meter, so 10 kilometer meter, it will reduce to 0. And we have seen the reaction is here 15. We can see the reactions also from taking a moment about this one. This value is 10 into, this is 2 into 1, that is 15, right? The load is so we have seen here, this is the load 10 kilonewton, this is 1 meter distance, this 2 meter distance. About this point, if you see, the moment will be 10 into 3, so it will be 30, and this force V equal to VB into 2 meters distance between these two, so VB equal to 30 divided by 2, that is 15, so 15 kilonewton upwards. So vertical, if you see equilibrium, this is 10, this is 15, so downwards it will be minus